super excited to share our new product that we launched, the capability that we launched in 5.4, Data Engine. Welcome to the overview session of Data Engine. What we have today in the agenda is what are the common challenges what enterprises face with AI, and what are the capabilities that the enterprise AI needs? What is VAST Data Engine, and how we power AI pipelines, and what we call what we call Insight Engine. We touch upon a developer experience. Data Engine is a developer platform where you can build in interesting, insightful AI applications and data applications. Simon would go into a demo, a very interesting demo, and then we would go into why VAST is different than the other alternatives, and then we'll close it out with questions. So let's look at what does enterprise AI truly need. First, it needs a unified data foundation that can handle all kind of multi-modalities in your data, whether it's structured or unstructured. Second, it needs real-time access. Your data needs to be fresh, to be fed to these agents to give you real-time information back to you. Third, it needs to perform at exabyte scale and performance. As you want to ingest your enterprise data, the scale plays a critical role, critical requirement to adopt AI. And finally, unified governance. You need fine-grained access across your data assets, consistent security and access control from the moment you see the data that gets ingested all the way till the consumption layer. So VAST Data Engine is part of the VAST operating system that transforms the platform into a real-time, event-driven compute backbone. It brings intelligence and actions to your data rather than moving data to the compute. This approach enables you in-place processing. You can process and transform data without replicating it. You can store multi-model data within the data store. It provides a unified workflow to automate your both real-time and batch workloads for your both structured and unstructured data by creating complex pipelines. It's real time. You can ingest data in real time, and it's built for performance. It's built on our DAYS architecture. It delivers zero latency for your data operations. And lastly, it provides unified data governance across your data assets for your pipelines, for your data that is ingested, and then your raw data as well. So what is a VAST data pipeline? It's a serverless event-driven compute framework where triggers and functions are used to build automated real data pipeline. It's an integral part of the operating system itself. It's integral part of the platform itself. And there are three key components of data engine. One is triggers. Triggers creates events, and these events are processed by our event broker. It is the Kafka-compatible broker that detects any object or data changes in real time. Example, when a document lands in the data store or a video lands in the data store. Then based on those triggers, you can act using what we call serverless functions. You can write and deploy Python functions that are pretty much stateless containers. We manage the whole scale up, scale down for you. And these functions can be things like data classification, data enrichment, PI detection, or even to simpler extent, metadata indexing to create a semantic layer. They're easy to use. Like I mentioned, no deployment. You just let the infrastructure take care of. We simplify that for the developers. And lastly, it has a containerized engine to execute our engines for structured data. We have Trino and Spark as part of managed experience within VAST platform. With seamless across the same data can be seen through all these engines. And what this enables you to do, interesting thing, like this is an example pipeline, AI pipeline for video analytics, where data is ingested and it gets stored within our vast data store. And we perform this AI pipeline of chunking, embedding, leveraging NVIDIA models. And this is something Simon would be demonstrating to you, both in terms of the data that get extracted, but more importantly, some of the interesting things and actions you can do with that data. Let's go over some of the key enabling technologies also that's part of our data engine. The event broker is natively integrated as part of our data engine. It provides the ability to act on the data changes. So any trigger gets processed by the event broker. It's fully Kafka compatible. So if you have Apache Kafka in your platform or in your use case, we could replace that with Vast Event Broker. One of the unique things about Vast Event Broker is that topics are stored as tables. So you don't need to do any ETL job or transformation job to make tables, make topics to tables. This is part of the product. So from ingest to querying, you can do it in near real time. Performance-wise, you can we released latest benchmark of we processed about 138 million messages per second. That gives about 2 gigabytes per second for each compute node, so which is very high performance and low latency event broker. The second component as part of data engine is the serverless function. This is the action layer for the platform. You can write Python code and automate the AI and data workflows. You can decide what you want to do. You can also, depending on what attributes are changed, you can change your workflow. There is no infrastructure overhead because platform manages the runtime, and it functions and it enables real-time use cases like automatic tagging, indexing, and metadata enrichment. What we realized also, a part of AI pipeline, there is a need to store the data that the agents and the AI layer can understand. And for that, you need a scalable vector database. So we offer a vector store that sits seamlessly along with your structured data. And we have designed this thing to scale to trillions of vectors. This enables real-time vector search and also helps you do interesting querying, like you can join between metadata and similarity search. So it unifies both structured and unstructured aspect of your AI pipeline. And crucially, we provide unified governance enforcing table, row, and column level security across both your raw ingested data as well as the data that's in vector format, as well as it's in the SQL format. This delivers unified governance across both your AI and analytics. For structured data, we include Trino and Spark. Spark for your ETL jobs, Trino for your BI and analytical queries as part of the platform. It's optimized for VAST all-flash architecture. It runs on vast compute nodes, so eliminates unnecessary network hops, and it fully leverages vast backbone for performance. So with that, you can eliminate the need for stitching together different components for your ETL and BI. So you have one platform that can do AI analytics in one platform. And also the benefit of having closer to our compute nodes, the queries are faster. In our results, we have seen 40x faster SQL queries for analytics. So it's one platform, one architecture, simplify the operation and security and governance model. I did touch upon the the governance model as a key thing. So with a unified AI governance, just to reiterate, the security policies are consistently applied across the data that is ingested, the raw files, as well as the data in the structured or the vector representation across the entire pipeline. There is no handoff or stitching together between systems, so you have full visibility into the data lineage as well as access patterns. And the way we provide is using the row and column level permissions, and also the ability to have the raw information stored with the structured data that gives you flexibility to access both in the single system rather than having multiple systems and manage that complexity. And these policies can be applied, defined once, and can be applied across all the different data layers. And it's enforced across all the consumptions layer as well. So let's look at an AI pipeline example end to end, how it works within VAST, and what are the different components. And it also it gives you, when Simon gives the demonstration, some of the things that is involved behind the scenes. So with VAST, you can ingest the data into our data store. Can be object, it can be file from your existing data assets. And this capability we simplify with Sync Engine. It continuously monitors the data and continuously ingests the data with the required permissions, a part of these ingestion framework. Once the data comes in, the platform triggers an event, which gets triggered by the triggered into the event broker. And from there, you can create the pipeline to extract insights out of, extracts information out of these objects. These extractions and embedding, you can integrate with, we integrate with NIMS model. NIMS is that what's shown, but you can integrate with in any other model like OpenAI or any others. And then you can store these embeddings within our vector database. And from there, you could now use different retrieval services or agents to do a retrieval of the data. And for structured data, also we have a data warehouse, the database that we talked about. And you can now create interesting integrations with your agentic applications. We support MCP capability, is soon to be released, and that would also be part of the platform. And again, you can create caches also as part of the memory, as part of the agentic application. And not to miss that out, it's powered by the unified security and the governance model, so that everything coming from ingestion to consumption is tracked within the platform. So what does these mean to you? All these capabilities on VAST, it helps you develop some interesting applications, because now it delivers a compute fabric where you can bring your own code. So it's actually providing a compute layer for the data that is stored and the workflow to act upon it. So examples and use cases could be your RAG workflows, your new video lands or a new document lands. You can automatically, once you create a pipeline, you can chunk it, embed it, and store it for retrieval. PI detection, classification, scan and mask sensitive data that you don't want to stay compliant. Real-time analytics, get fresh data. It can be between structured sensor data, for fast access of the data for your agents or your analytical layer. And then other interesting thing that most customers use our platform for is metadata enrichment. As the data comes in, you can retrieve metadata and get more insights out of what kind of data and what is stored within your platform. Yeah, bottom line is instead of just storing just raw data, VAST lets you gather insights out of this data, and you can automate and enrich and make it usable to your business at scale. As I mentioned, this is a developer platform that lets you build interesting applications on top of it. And I want to touch upon what those experience looks like. So we provide a developer-first API and SDK for building these pipelines. We have a zero-code approach where it's UI-based. It's a studio where you can build this without knowing any code. Also, we provide, you can use your favorite tool to build this. It's a YAML. The file that gets built is the YAML base, so you can use your UI or a CLI or your own ID and then work with that. And once you work with the platform, once you upload your functions and triggers as a package, then the platform manages the infrastructure scaling and resiliency for you. You don't have to think about that. So what does that experience look like? So it essentially breaks down into four key aspects. One is you write a function. You can write it using your favorite CLI or an IDE. You build an image of those functions, and you deploy that function to DataEngine. And now using those functions, you can now stitch those functions to create a pipeline. Again, you can use it through UI or a CLI. So that's essentially from at a high level that you do end to end, and then you deploy it on the DataEngine, and we manage the infrastructure part of it. I also want to touch upon the deployment architecture a bit. So in 5.4, it's the data engine could be run on an external Kubernetes. It doesn't run within the compute engine of VAST right now, but you can create a separate cluster where you can. We need about three nodes for Kubernetes, and we deploy this on those Kubernetes nodes. So how it works is the VMS deploys an operator, and that operator manages the life cycle of your containers, and it interacts with the image registry where you publish these functions. And then at the end, it runs on a Kubernetes cluster where it scales up and scales down. And then the logging and tracing is all collected as part of the VMS and the experience that Simon would show. In 5.4, if you have models, you have to make an external call. In future, we would make it part of the platform. So in this case, you can call a name or model that is outside through an external API. So that's at a high level how the architecture works. With that, I'll pass it to Simon to go over the demo that will touch upon some of the components that I just shared.
Thank you, Prasid. Hello, everybody. I'm going to share my screen. Just a second. Perfect. Can you guys see my screen? I guess so. All right. All right, guys. So I'm going to shortly just touch up the end-to-end pipeline that we've built, okay? And then we're going to go and see the end-to-end flow, how we build a pipeline and how we invoke a pipeline on VAST DataEngine. But first, let's see let's see basically the flow in the architecture. So we're going to see a quick flow of end-to-end video real-time processing pipeline, okay? And of course, as in each pipeline, we have the ingestion part, and we also have the retrieval part. So on the ingestion side, we're basically going to have a pipeline which going to stream chunks of videos right to VAST S3 buckets. This put operation is going to invoke basically a set of functions, and this set of functions going to represent the full end-to-end ingestion pipeline until the whole data is reached to VASTDB, together with all the gathered metadata across all the different functions, and also together with the vector store, and basically with the embeddings that were embedded using the endpoint of the embedding model. Now on the retrieval part, we of course need to have some user interface, which will be a semantic search in our case. This semantic search will be also embedded using a model. And then we will go through some filters of full ACL, and then we will perform a similarity search, and then we'll retrieve the video. All right, now let's take a quick look on the left stack. This is basically all the benefits that we gain already with just having a VAST data platform. And basically, we have all the views and buckets and NFS views and all other protocols and entities that we create on the VAST data platform. We will have the VAST-DB, which stores all the metadata and the vectors. Of course, we need an internal event broker, which is responsible for receiving and streaming all the events for invoking the functions. And all this operation is basically built on top of Knative, and we're using a VAST data operator in order to bridge the events from VAST to Knative and the other side. All right, let's go ahead and log into the VAST data engine. All right. So I'm going to log in. And the reason I always like to start from the login level is because I want to highlight that everything is basically can be tenantized, and all the elements that the user sees inside the data engine are fully tenantized and can be used within, all kinds of users and all kinds of business units, organizations, and within different groups. And basically, each user will see only its own elements, only its own NFS views or S3 buckets, and of course, only its own databases. Okay, now this is the dashboard of the data engine, and it's intentionally right now I don't have any invocations because we're going to invoke the pipeline together with you. But let's look at the elements quickly before we invoke the pipeline, okay? So first we need a trigger. Of course, in every pipeline, you need something to invoke the pipeline. So this is what we call a trigger. And let's look at how the trigger looks on the data engine. So for example, here I have a trigger which is called video chunk length trigger. Okay, and basically this is a pre-processed trigger that invokes a pre-processed function, which means that whenever a video chunk is landed to a certain bucket on VAST-DB, on VAST data, we want to invoke the pipeline and start up the set of functions that we want to use within this pipeline. Okay, so for example, in this trigger, I'm saying that whenever any element is created in video chunks dev bucket, I want to send an event to the VAST internal broker to this specific topic. And this event will basically start up the Knative revision function and invoke the full pipeline. And this is how a trigger looks. And by the way, we can also create a schedule trigger. And this means that this trigger will be invoking the function, for example, every 5 minutes, okay? And this is without a specific element landed to the bucket, but this is a schedule trigger. Okay, and we can also basically create triggers on whenever any element tag is created. For example, if some ACL permissions for the specific object has been changed, we also want to invoke the pipeline and process this object again. So this is how a trigger looks. Now let's take a look at the functions. So we want to see how a function looks. So let's open it up. Okay, so this function is called a video segmenter. Again, this is the same function that is invoked by the previous trigger. So basically, when I have some video chunk landed in the bucket, I want to invoke the function that will take this chunk and divide it into set of segments of the video. So basically, I can process them orderly and I can store them inside VAST-DB in continuation. Okay, so basically, we have the artifact source of the function, okay? And you can see this is, I'm using, in this case, I'm using my own private GitHub repo. And this is to highlight basically that this system is basically created for the developers, and every developer can use their own container registries. And basically, you can also use tags if you need to tag specific functions and you want later then to serialize them and to filter them in your element store. Okay, so this is a function. Now let's take a look at the pipeline. Okay, so we have triggers and we have functions. Now it means that we can create pipelines. So let's take a look and now at our existing pipeline over here. Basically, this is the end-to-end pipeline of our video demo, okay? So on the first step, we have a trigger, which is invoking a function to divide the video chunk into segments. And on the other side, we also have a trigger that is triggering another set of functions whenever a video segment is landed on a different bucket, okay? So whenever the segment is landed, basically we invoke other three functions, and the first one is basically taking the video chunk and sending it to the NVIDIA Cosmos model. In this case, we are using the Cosmos Reason 1, which we're going to see later. But I'm just going to say that we are fully model agnostic, and we just approach, the function is approaching an endpoint. It can be a cloud endpoint on NVIDIA Cloud. It can be some other vendor model, and it can also be your own hosted model in your GPU host or your GPU center or some DGX server. Okay, so this is for getting the reasoning of the video. After that, we're getting the reasoning in a text representation, and we want to embed this text into embeddings in order to store it into VAST-DB. And then basically the vectors and all the metadata that has been gathered and collected through this pipeline is stored inside VAST-DB. Now, what is also nice to highlight is that you can, from this interface, when you deploy the pipeline, you can basically configure the resources for each function separately, okay? And this is the resources that you provide to your Knative revisions, and which is basically means that you have a fully managed Knative platform that you can leverage using the data engine. Okay, so you can basically configure the resources, and you configure the resources and the revisions and the concurrency of the function. All right, now let's invoke the pipeline. Okay, so right now, guys, I'm going to log in into what we call a video reasoning lab. Okay, and right now I just want to configure a streaming to simulate, basically to simulate you that that we can live stream a video inside into the data engine, and we can already process this data and retrieve upon of it. Okay, so I'm just gonna take some random New York City bike cameraman that is randomly riding in New York and filming the streets, and we're gonna see that later. So this is the URL of the YouTube video, and we're gonna title the streaming. We'll say NYC 55. We want to have intervals of 5 seconds. So basically, each 5 seconds, I want to invoke the function and process this video. And we also can attach some metadata to each object that will be created. So let's say, for example, this is camera ID 55. We're streaming live traffic videos, and let's say this is in somewhere in the Midtown NYC. And let's start the streaming. Okay, now this will basically start a live streaming to the data engine, and basically we'll start to drop chunks of the videos to the S3 bucket, and in real time invoke the function. All right, so we can see that instantly, basically we're starting to get events on the dashboard, and we can see the total events and invocations per second, and this will start to grow. And we can, okay, so we've got a few events already, so we can go to the pipeline observation, because we want to see what's happening now within the videos that we process. All right, so let's look at the logs from the last 5 minutes. And let's see what's happening. Basically, we can see that the observation here is really basically informative, right? And we can basically see each and every step within the function. We can correlate the log to a specific function that is running right here. And basically we can see right here, we can also see the metadata that was attached to the files. And basically we can see the end-to-end processing, and we can live monitor what's happening within the pipeline. And if, of course, if something is failed, then we'll get error logs here with error level, and we'll be able to deep dive and understand what's happening. Now, just a side note, guys, of course, these logs are written inside the function. So basically, you write your own code, you write your own functions and your own logs to the Python code, but you package the function that you write, you package it with the VAST DataEngine builder. So we provide you a builder, you package the functions with our builder, and then you basically push the function to the container registry. Once you package it with the VAST DataEngine builder, This is how the logs are basically flowing to the data engine interface. And of course, they are also flowing together with the traces. So if you properly write the code with your trace ID, so it means you will also be able to get traces to the VAST data engine. And again, you'll be able in live to see and monitor what's happening with your functions. So for example, if I want to see, let's look at some interesting trace. So let's say I want to see, okay, I want to see how long it took to embed the videos. So let's go to the function, and we can see, okay, the segmentation. All right. So basically, we can see that each step, we can see the duration and the attributes that we've added within the code. Okay. All right. And this is how a pipeline is involved, and this is how a pipeline is built from triggers and functions. We can go back to the dashboard, and we can see that the streams are still going on. All right. So now we want to understand what we can do with it, right? So we have built some interface, which is the application side, to retrieve the chunks and to perform a semantic search on top of the VAST-DB together with similarity search. But again, this interface is the application side, and it's basically your own choice what you want to build with it and what you want to achieve with it. This is just an example. But once you have the ingestion part, which is handled by the data engine, it's your choice what you want to build for the retrieval part or for the other use case that you have. Okay, but anyway, we will have a pre-built ingest and retrieval pipelines like this one embedded into the data engine, and you'll be able basically to use them easily. We'll have them repackaged for you. Okay, but just a side note. All right, guys. So let's perform some interesting searches. Okay. So as we said, we are tracking some random videos from New York City with some random guy riding on a bike. All right. So in this time, I want to basically find all the segments that showing some some buses are stuck behind some construction zone or maintenance activity. Okay, so basically imagine that I'm controlling. I'm in some control room in New York City, and I'm just receiving the events if something is going on the road and something is stuck due to some construction activity. So I want to understand if there are some buses stuck behind maintenance, and let's search for that. So in this search, basically, we are showing that we are generating the embeddings from the prompt, searching the VAST-DB for similarity. Of course, we apply the permissions, which is basically means that each user can see its own videos, and you can control by users and groups who is exposed to what data. Okay, and basically we can really see that there are some buses stuck under some maintenance work. All right. So now let's try something more clever. This time, I want the system to tell me the bus lines that are blocked by the construction, okay? And this time I'm gonna enable LLM reasoning. What it means basically is I'm taking the top answers and basically send them back to LLM to get the reasoning and analyze the chunks and retrieve with human readable answer. And also, this time I want to know, I want to ask this question for a specific date and a specific time. Since I know when this happened, I can basically let's have a 5 minutes window. 5 minutes window. So, all right. So specifically on the 9th of December, I want to know which are the bus lines that were stuck behind the construction. And let's see if it will give us a reasonable answer. And yeah, that's reasonable. So basically we can see that bus 9443, M12 bus, was stuck on this specific date and time. Let's see if that's the true. And we can see that this is really the bus in the beginning. This is the bus ID, which is fine. All right. Now let's have another last search to maybe give you something more spicy. And I'm gonna search. This time I'm gonna do it without the time selection, and I'm gonna say, okay, is there some new collision scenes on West 34th Street? And let's see if we get some videos. All right, let's see. Yeah, the LLM is telling us that there are some activities recorded, and let's see. Okay, and we have some person walking on a red light on West 34th Street. All right, guys, and again, we are basically, this is the video example, and whatever you want to do with the data engine, if it's embedding documents, creating processing pipelines, and processing other documents or videos, you can do it. That's it for now from my side, and thank you,
Simon. Yeah, you saw what the way the data engine, how it makes it easy for you to take the Python code, and what are the things that we are doing in the backend. We've been managing the scale up, deployment, life cycle, also some of the traceabilities and the metrics that Simon shared. With that one, I'll go back to my slide. Few things to cover, a few things to touch upon. To summarize, so why VAST, right? You've seen that we are bringing together different technologies and different capabilities that enables you to create a pipeline and AI application to the data, some insights to the data within the single platform. If you compare with the traditional approaches, which is pretty much fragmented, you pay an integration tax to stitch together these components between different interfaces for capabilities as well as for governance. And with VAST, we want to provide a unified platform where it manages these complexities. It eliminates the data silos and reduces, and you don't have to pay the integration tax to build these interesting applications. And also, last thing, if you want to try things that Simon shared, it's available on GitHub. Go download it and play it. And our team is here to help. So that's another thing I would encourage everyone on the call if they want to give a try. With